Right, this is a satellite and gravity question. And we've got this small planet here somewhere in space, and a chance of an alien living on that planet visits Earth, and he finds that he weighs the same on Earth as he did on his home planet, even though the Earth's much larger. He weighs the same. Now weight, or the force of gravity, is always equal to mg. His mass will be the same, so therefore the gravity on both cases must be the same. Earth has a radius of this, mass of this, and that's Earth's gravity, 10, which we're used to. What's the value of the gravitational field on the visitor's planet? It must be the same. It's only one mark, don't have to do any working. Easy. What is the mass of the visitor's planet? Explain your answer by showing clear working. Okay, well, one of the formulas you have in your cheat sheet is that gravity equals the mass of the planet, or the thing that's being orbited, times gravitational constant over r squared. So if you rearrange that to find mass, you times both sides by r squared, divide by big G, and let's put the numbers in. How big is this planet? What's the radius? Well, we've got 10, that's gravity, and then r squared. Let's find r. Earth's radius, but we want to look at the radius of this planet. Radius is 30 kilometers. Here we are, radius. Now 30 kilometers, we don't like to use kilometers, so that's 30,000 meters. And that's squared all over G, gravitational constant, which is here. 6.67 by 10 to the minus 11. When you calculate that, I get 1.35 by 10 to the 20 kilograms. Alright, last question. So I've just copied and pasted the picture up the top again for question 23. What is the time period of orbit of the visitor's planet? Show your workings. So they've given us this new information here. The visitor's home planet's in orbit around its own small star. That's the radius of orbit r. The star has a mass of this. So on your cheat sheet you'll have the following formula. You'll have T equals the square root of 4 pi squared r cubed over gm. What m do you use? The m you use is always, when we're using this equation, m always the thing in the middle. Alright, they're talking about the planet going around the sun. That's my picture of a sun. It's awful, I know. There we go, he's wearing sunglasses. The planet going around the sun, they've given us the radius of that orbit, and they've given us the mass of the star, the sun. That's the mass we use, it's the thing in the middle. So instead of using the mass we calculated last time, we're going to use this new mass. Now this is just a case of putting all the numbers in. 4 times pi squared times the radius of the orbit is here, 1.1 times 10 to the 9, it's cubed, over G is 6.67 by 10 to the minus 11, and the mass is 5.7 by 10 to the 25. To get the right answer, and the right answer is, after you do the calculation, I get 3.222, 400 seconds, which equals 3.22 by 10 to the 6 seconds. The hard part about this, or that a lot of students find hard, is doing it on your calculator. They always get the wrong answer on their calculator. So if you're happy with that, leave it like that. If you want to know how you do it on your calculator, stay listening, and this is how I do it on my calculator. So the first thing I type out is I do this top one. So this is what I type into my calculator. I type 4 times pi squared times 1. Now I'm typing this out here. 1 by 10 to the 9. Some students type out 1 and then they times by times and then they write 10 and then they say to the power of, etc. I don't like using that at all. I'd rather use the button on your calculator that says EXP, and when you press that, a 10 to the power of comes up automatically. So I write 1 EXP 9 and then I do to the power of 3 and then I push equals. And just so you're following along, you can check that gives 3.95 by 10 to the 28. After I've done that, I get that answer, and some of you have got an answer button on your calculator, some of you have to push second function answer or shift answer. But usually the answer button's down near the equals, but I get the answer and I divide it by bracket all of this 6.67 again exp exponential, which is 10 to the power of, minus 11 times 5.7 exp 25 end of bracket equals. So I've taken the top, which was your answer, and I've divided by in brackets this bottom. You've really got to make sure you put these brackets in. And then that gives me, if you're following along, you should get the same answer, 1.04 by 10 to the 13. So that's all of this inside the thing, and then I put square root, and then I square root my answer. So that might be second function answer or shift answer, or there might just be an answer button ready to go. And that gives me my answer of 322.400 seconds, which is what we got here, and we just put it in by 10 to the 6. The way I do it in 10 to the 6 is you count how many times the decimal point has to move. 1, 2, 3, 4, 5, 6 by 10 to the 6.